Hi, this is the lesson video for 3.4 optimization. So for this lesson, we are talking about optimizing. So we're looking at using the first derivative in order to find first and or second derivative in order to find maximum and minimums in word problems. So let's jump right into it. We've got a farmer that has 800 meters of fencing and wishes to enclose a rectangular field. One side of the field lays against a country road, okay, and that's what this represents right here. Let me just get my that's what this represents, the country road. And the fact that we have 800 meters means that if I let this represent x, then with 800 meters of fencing, I take away 2x, and that's how much fencing I have left for the side parallel to the farm. One side of the field is against a country road. The farmer wants to enclose a maximum possible area and use all of the fencing. So I see maximum, I see area. How does the farmer determine dimensions to achieve this? So first off, let's start with area. Area is length times width. So we have our length times width. That is my area formula. Now if we're looking for max min, we're going to find the derivative. And that's what we did here. Finding the first derivative, we get negative 4x plus 800. And then we solve for x. Okay, so rearrange, solve for x. You'll get x is equal to 200. Okay. Once you get x equals to 200, we want to know whether it's a max or a min. Okay. So what we do then is take the first derivative and find the derivative, and we get a second derivative is equal to negative 4. So that tells us it is concave down. Well, if it's concave down, that tells us that it's going to be a maximum. Okay, so now we check endpoints, and then we have our answer. So our domain is going to be between 0 and 400. Well, why? You can't have a number less than 0, because if this value here, this width of this rectangle is 0, we don't have a rectangle. It can't be 400 either, because if you think about it, you have 800 meters of fencing, okay, and you decide to put, here's the farm, 400 meters there. Well, how much do you have left? 400, which means you have nothing for the length or the width, which means you just have two pieces of fencing, both 400 meters long, on top of each other, okay? Which means that's the absolute maximum, okay? And then, so we check the endpoints. If x was 0, then the area would be 0. If x was 400, the area would still be 0, because two pieces of 400 meter fencing won't create a rectangle, which means you have no area. So what if you had 200, which is the number we found from the first derivative? Plug that into the original function and you get an area of 80,000 meters squared, which is obviously the highest number between 0, 0, and 80,000. So the max area is 80,000 meters squared. Question 2. You've got a piece of metal, 30 by 20. It's used to make an open-faced box. This is supposed to say 30 by 60, not 20. 30 by 60. Okay. Determine the dimensions that will maximize the volume. So the volume of any box or rectangular prism would be length times width times height. Okay, which means we have length times width times height. Okay. Now where did these numbers even come from? Where did 60 minus 2x come from? Well, you've got a piece of sheet metal, so this whole thing is 60, right? Okay. Now, if you were to fold that up, well, fold that up, so pretend this flap is folded up, okay, and this flap was folded up to create a box like this. Well, the height will obviously be x, because that's how long these boxes are. But how about the length? Well, the length is, we know this whole sheet is 60. Well, I know this side here is x. We also know this side here is also x. So then, how long is this from here to here? It's 60 minus 2x. Same reasoning for this length here. Okay? 30 minus 2x. Length times width times height. Okay. Once we have that, we just find the derivative. Okay, so it's a triple product rule. Okay, so find the derivative of the first term, copy the other two. First bracket, find the derivative of the second bracket, copy, copy, find the derivative of the third value, which is just an x, and the derivative of that is just 1, but I did not include it there. Okay. Once you have the derivative, expand, simplify, okay, and you will get this equation. So now you try to factor that. Two numbers that multiply give you 150, but add to give you 30 does not exist. So you use the quadratic formula. The quadratic formula, which is right here, where a is 1, b is negative 30, and c is 150, you get these two critical points, 6.34 and 23.66. 6.34 and 23.66, okay? Then I'm going to use the second derivative just to see if I get maxes or mins, okay? We're looking for a max. Remember, the question is asking for a max. I find the second derivative, solve for x, and I get 15. So here's my first critical point, here's my second critical point, and the 15 in the middle separates the two, okay? Now, using 6.34, I want to know if that's a max or a min. Well, so I choose any number less than 15, plug it into the second derivative, or I can plug in 6.34. I can just plug in 6.34 into here, okay? And I will find that this number will be less than 0. I don't care about the value itself. Just by plugging it in, I know it's a negative number. Plug in 6.34 into the second derivative, okay? This is supposed to say second derivative. And you will get a negative value, which makes it concave down. So if it's concave down, that means this is a max. Okay. You do the same thing for the other critical point, sub it into the second derivative. So again, I could just sub in 23.66 there. Okay. By subbing that in, that opens up, which makes this a local minimum. Okay. But again, the question is asking for a local max, so x is 6.34. So we had a max of 5196.15. Now what I didn't do for this one is check the endpoints. Okay, so if x was 0, okay, if x was 0, that means 0 height. Well, what would the volume be? The volume would also be 0. If there was no height, you have a 2D shape, you have no volume. If x was, well, what would the highest possible value of x be? The highest possible value of x would be 15. Okay, why is it 15? Well, if you look at these two, okay, take a look at that. 30 minus 2x, if that didn't exist, so that's like saying 30 minus 2x equals to 0. If that didn't exist, then I solve that, I'll get x equals to 15, which means if x is any bigger than 15, okay, this wouldn't exist. Because looking back at this sheet, for example, this sheet of 30 by 60, if x was 15, that would make 15 here, 15 here, because 15 plus 15 is 30, then our box wouldn't exist. So then we check 15 as well. Okay? And if you sub in 15 into this, well, we just established that 15 will make this equal to 0. Length times width times height will also give us a volume of 0. So, indeed, 6.34, if x is equal to 6.34, plug that into my calculator. So plug this into the original function. So that is this function right here for the volume. And you'll get a maximum volume of 5196.15. Okay. All right. Next question, example number 3. Ian and Ada are both training for a marathon. Okay, so here's Ian, here is Ada. Okay, Ian's house is located 20 kilometers north of Ada, so which means from Ian to Ada, it's 20 kilometers. At 9 a.m. one Saturday, Ian leaves his house and jogs south at a rate of 8 kilometers per hour, which means that he's traveling at 8 kilometers per hour. Negative, so 8 kilometers per hour. Now, which means that this triangle, what would that length be then? That distance? Well, it would just be 20 minus 8 times t. Why? Because t represents hours. If 1 hour passes, okay, then that means they've traveled 8 kilometers in that hour. Okay, which means what's this distance highlighted in yellow? 20 minus 8, that'll be 12, right? If 2 hours pass, that means he would have traveled 8 times 2, so 16 kilometers per hour. 20 minus 16, that will make the highlighted yellow part 4 kilometers. So that's why this section here is, this yellow highlighted length or height is 20 minus 18. What else? Ada leaves her house at the same time and jogs at a rate of 6 kilometers per hour. So Ada starts heading this way, traveling at a rate of 6 kilometers per hour. Okay, which means Ada, her rate of travel, okay, so I'm going to say just dA over dt, A for Ada, okay, is 6 kilometers per hour. Okay. Now, our job is to find S, so minimize S. Well, what do we have here? We have a right angled triangle. Okay, so a squared plus b squared equals c squared. So a squared plus b squared. 6, so this distance, this would be 6t. Okay. Reason for that is 6 kilometers per hour, 1 hour passes, distance traveled is 6. 2 hours pass, 6 times 2 is 12, and so forth. So a squared plus b squared equals s squared. So a squared plus b squared equals c squared, right? Now we have the formula. Okay. Now our job is, I'm just going to rearrange this. So just square root all of it. Okay. Then I get s equals to this formula with respect to time. Now all I do is find the derivative. Okay. So that's the power rule and then the chain rule. This is the derivative. Okay. All I did was move this part to the front. Simplify the numerator only. Okay, leave the denominator. It simplifies down to negative 320 plus 200t. And then I set that equal to 0, and I find t is equal to 8 over 5, which is about 1.6 hours. Okay, so what that is saying is at 1.6 hours, if Ada heads east and Ida heads south, or sorry, Ian heads south, then in 1.6 hours, their distance, the distance between them, which is what J and B signify, will be the smallest. Okay, so at 1.6, then I plug these numbers back into the derivative. Okay, the first derivative, and I find that this is decreasing, this is increasing, and then so 1.6 hours, there will be a distance of 12 kilometers between them. Min distance occurs at t equals 8 over 5 hours with a min distance of 12 kilometers. Okay. The last question is pretty much the same thing, but if you have any questions and need clarification with it, let me know. Okay, talk soon.